plan to post homework to today. It will be due next week on the 21st. So I am using the book as a guide for the notes for the most part. But again, you didn't have to buy a book or you don't have to buy anything for the class materials. We're just taking notes and using Canvas. Okay. We want to finish section 15.1, which is about histograms. The following table. There are classes and their frequencies. The first class is 80 to 85. With the frequency of 3. Then we're going 86 to 91. The frequency is 2. From 92 to 97. Frequency of 4. And 98 to 103. Frequency will be 6. We need a place for classes, and then the other will be frequencies. I like to put the classes on the horizontal side. And I'm going to put a little space between 0 and 80, and we're going to place 80, 86, 92, 98, and 104 on. And then looking at frequencies, the highest value is 6. Halfway and call it 3. 1, 2, 3, 4, 5, 6. Okay, for your first class, we have a bar with height 3. Okay, from 86 to up to, but not including 92 is height 2. Between 92 and 98 is the height 4. And your last bar is a height of 6. All right, we're gonna do one more of these and then move on. Okay, draw a histogram for the following frequency distribution. Classes, frequencies. First class goes from 20 to 29. Its frequency is 10. Then from 30 to 39. Our frequency is 7. 40 to 49. Its frequency of 3. The last one goes from 50 to 59. And its frequency is 1. Okay, classes on this side, and I'm going to put space between 0 and 20, and then label 20, 30, 40, 50, and also 60. And here, the frequency goes as high as 10. So let's start with 10. And cut it in half. Here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now that I've got some units labeled, let's go to that first class, all the way up to 10. Next class between 30 and 40 is a height of 7. Okay, 40 to 50, we're going up to 3. Last one is the height of 1. That's our histogram. So we're starting section 15.2, and the main topic is mean, median, and mode. So before we get to those definitions, I want to talk about sets. So back in the previous section, we defined a set. And we talked about how there is no order in a set. And duplicates are not counted. We're going to start talking about a data set. So even though it has the word set in its name, it's not quite the same because we will have duplicates. So it's a collection of numbers that represent all the values obtained when measuring a characteristic of a population. This is where we're moving more towards statistic types of questions, where we have a group of people or a group of a population of some sort, and we are interested in some characteristic from that population. So we sample everyone and measure that value. Okay, so the data set is not a math set because repeated numbers are included. Actually, let's not do quotes around this data set. Not a math set. Okay, so it is not a set like the sets we've been talking about. It is more of a list. And we're going to put that list in curly brackets. I think we're going to go with an example that's a picture, and we're going to compare the previous pictures we had to the current ones. So over here in section 15.1, we talked about the sets. And then in 15.2, I'm starting with data sets. Pretty much this sort of the same idea. In the previous set, our universe was more of a square shape. We called it U. And we had elements inside that were not no repeats. So let's go with like 3, 4, 5. In our data set, we could draw a square, but usually in a stats book, it's a big circle and it's called a population. Let's say that there are 5 people in the population and we're interested in maybe like how many I'm going to go with like the question we had earlier with how many cats that person owns. So the first person doesn't have any pets, so it's a 0. Second person has 1 cat. And this other person also no pets, so no cats. And then we're on this 4th person, we ask them how many pets they have, and they say they have 2 cats. And then the last person happens to have like 4. So you have this repeated number, but they're separate values. And all of those numbers are representing some measurement of a characteristic of your population. All right, so we're going to introduce summation notation. Let's start just with the symbol. So this symbol means sum or add. Okay, so we're going to say, we're going to let the set contains x1, x sub 1, x sub 2, x sub 3. Right, we'll go like x4, x5 until you get to the end. And we're going to call that x sub n, capital N. Okay, this is a set with 1, 2, 3, 4, 5, 6 up till you get to n numbers total. Okay, the first one we call x1. So x sub 1 is the first number. x sub 2 is the second number in the list. x3 is the third number, x4 is the fourth number, until you get to x sub I, which we call the ith number. Okay, so we're going to go to this notation where we have the sum from I equals 1 up to n of your x sub I. So you put in I equals 1 first, and then you put in I equals 2 and I equals 3 until you get to the last number, I equals n. It's x1, add x2, add x3, add up to x sub n. So for the following data set, that contains 1, 2, 1, 3, 7, 9. Find the sum from I equals 1 to n of x sub I. And I'm also going to put what capital N is. So just again, saying it again, capital N is the number of elements in the set. We have 1, 2, 3, 4, 5, 6 total. So capital N is equal to 6. Sum from I equals 1 to 6 x. I'm going to put x1, and then add x2, add x sub 3, add x sub 4, add x sub 5. And that's x1, that's x2, x3, x4, x5, x6. So it's 1 plus 2 plus 1 plus 3 plus 7 plus 9. Oops. Okay, this would be 10 plus another 10 is 20. 21, 22, 23 is the sum. for the data set that contains 2, 5, 8, and 2. Find the sum from I equals 1 up to 4 of x of I. Excuse me. Okay. So just pointing out that that 4 comes from having 1, 2, 3, 4 elements total. This is x of 1, here is x of 2, x3, x4. So we sum from I equals 1 up to 4 x of I, which means first put in 1 for the subscript x1. Add. Put in I equals 2 to get x of 2. And here again, add x of 3. And now you've reached the top where we're putting in x of 4. So we want 2 plus 5 plus 8 plus 2. 10 plus 7, I've got 17. So a little more notation. There's another way to write this sum. So we're taking this sum from I equals 1 up to n of x sub I, and we can write it as the sum of all I x sub I, and understand that this means the same thing as this. And what we're going to write down in words that what we want to do is just add all of the data values together. Cool. More practice. For the data set, that starts at or that contains 74626 -3 and -6. The sum of all I for x y. Sum of x. Okay, and we just want to take all the values in the set and add them together. So we're going to take 7 plus 4, 6. Add Add 2, add 6, add -3. And we're going to add a -6. Okay, let's start with that +6 and -6. 0. Let's keep that 7 right there. 4 plus 6 is 10. Plus 2 minus 17 minus 1, 6. And that's the sum. For the data set, that contains -20, 0, 4, and 7. Find the sum of I, x of I. So we're adding all of our data values together. Sum of all I for x of I is -20 plus 0 plus 4 plus 7. -20 add 11. The difference between 11 and 20 is 9, but this negative value is larger, so it's a negative. I like to put a square. That's why. Highlight my answer. Okay, one more. For the data set that contains -22. -10, -4, and 2. Find the sum of all I for x sub I. Okay, so add x sub I for all I, which means take -22, add -10, add -4, and then add 2. Let's put these together. -32. Here, this would be a -2, so -2. 34. So sometimes, like let's say working as a tutor, I've seen people ask what capital N means. So we just want to restate that capital N represents the total number of values in a data set. And now we want to define the average of a set. So the average is a measure of center, and the average is also called the mean. And what you do is add all of the values together and then divide by the total number of values. So we're adding up all the values in the data set and divide by capital N. We're going to use the notation to sum x sub I for all I, and then divide that by N. In words, we're asking to add data values. Then divide by capital N, where capital N is the total number of data values. So for the following data set, find the average. Okay, it's the set that contains 15, 20, 25, and 60. So we're going to take the sum. Let's start here. Start with average is equal to the sum of x sub I. Capital N is the number of elements we have, which is 1, 2, 3, and 4. And then the sum of all the data values is 15 plus 20 plus 25 plus 60. So this is 35 and 85 and so 4. So 120 over 4 is going to equal 30. So for the next data set, we're going to find the average. Our set contains 0, 1, 0, 1, 5, followed by 0 and 2. So our average is the sum of all x and y divided by n. We're going to take 0 plus 1 plus 0 plus 1 plus 5 plus 0 plus 2. Divide by 7 right there. 1, 2, 3, 4, 5, 6, 7 elements total. All right, let's see. 2 plus 5 is 7, 8, 9, 9/7. And on a test or something, you can leave this as a fraction, or you can write it as a decimal. Either way works for me. Okay, we're going to find the mean. This time it's -5, -13, and 2. Okay, so mean is just another word for average. We're going to sum x of I for all I, and divide that by capital N, which looks kind of intimidating, but again, add all of your data values, divide by the total number of elements in the set. -5 plus 10 plus -13 plus 2 over 1, 2, 3, 4. This is 5 plus 11, -11. And it's divided by 4. So we've got -6 over 4, which we're going to simplify. Here. So don't forget that minus sign. 6 can factor as 2 times 3. It's 2 times 2. 2 over 2 reduces to 1. And you're left with a negative 3 halves. One more. Find the mean. Our set's going to contain 0.5, 2, 8.5, 10, 15.5, and 26.5. So mean is equal to the average. Which is where we sum x sub I for all I and divide by n. I'm going to work that out at the top. Right, 5 plus 2 plus 8.5. Add 10 and 15.5. Add 26.5. Divide by the number of elements in this set, which is 1, 2, 3, 4, 5, 6. Let's just put these together. 2.5 plus 18.5 plus, see, that would be at 42. So 6. In the numerator, I have 63. And then divide by 6. And then we can simplify this. 63 factors into 3 times 21. I can write 6 as 3 times 2. 3 over 3 is going to simplify to 1. And what's left is 21 over 2. Awesome. We're going to introduce the median, write down the instructions for finding it, and then next time we'll actually practice. So the median of a data set is the middle value of the set once it's been written in increasing order. Okay, so I've got some steps. First step is to write your list in increasing order. So in the middle, in step 2, we're going to go to the middle, but 2 things can happen. Step number 2. Okay, value or values. So either in step 2, you have part A, where there's an odd number of data values. Odd. If it's odd, then the median is exactly in the middle of the list. So an odd number of values, they've all been written in increasing order, and you kind of move towards the middle, and you have one number right in the very center, right in the very middle. But if it's an even number of values, there's going to be 2 numbers in the middle. I'll tell you what to do. Part B, even number of data values. We're going to use the median as the average of the 2 numbers in the middle. The median is average. So again, we'll practice on Thursday, but we'll put our list in increasing order. If there is an odd number of values, we're going to go to the middle and use the number right in the center. If it's an even number of values, we're going to go to the middle and take the 2 numbers in the center and find their average, and that's our median. Double checking. You know, we have a little extra time. So my other class didn't make it to an example, but I feel like we can do one really quick one, and then we'll say goodbye. Okay, so small example. the set that contains, we're going to put them in order. 2, 6, 10, 12, 14, and so I took care of the first step for us. I put the numbers in increasing order. 2, 6, 10, 12, 14, and 20. We start to work on step 2, where we cross out the values until we get to the middle. Okay, I've gone in here to here to here, and there's 2 numbers in the middle. So we'll find their average. Median of this set is 10 plus 12 over 2. That would be 22 over 2. Which is 2 times 11 over 2. 2 over 2 reduces to 1, and you have 11 left. Which, like right between 10 and 12 is 11. So that number cuts that right in half and is right in the center of that list once we've arranged it in increasing order. Okay, that's enough for today. So this is the end of the notes. We'll come back next time and keep practicing mean, median, and mode.